Hello everyone, and now we are coming on to our next topic in this module, which is indices. Okay, let's have a look at some of these questions. So we're going to be dealing with, well, first of all, let me write down some index laws. So if we have got a to the n and we multiply it by a to the m, that goes to a to the n add m. If we have got a to the n and it's divided by a to the m, that is the same as a to the n take away m. So there's a couple of index laws. Now if I have, this is the one that we're going to be predominantly concentrating on, if I have a to the n to the m, then that is equal to a to the n times m. Okay. And because multiplication is commutative, this means also I could write that a to the m to the n is the same thing. So all three of those expressions mean the same thing. When you have a power to a power, it's a product. Okay, so those are predominantly a few of the laws we're going to be using. Another one is if I have ab to the n, that is the same as a to the n b to the n. And finally, for now, if I have a over b all to the n, then that is the same as a to the n over b to the n. So there's a few index laws for us, index laws. Okay, and perhaps you would maybe want to pause the video and make a note of those. But without any further ado, let's move on and have a look at a few questions. So first of all, I would like to look at perhaps question 3K. Let's look at question 3K from this worksheet. And question 3K says the following. It says 5 rs squared cubed, and that is divided by 10 rs squared. Okay, now let's have a think about this. So using the laws that we've outlined above, in fact using this law here, this can be thought of as 5 cubed r cubed s squared cubed divided by 10 squared r squared s squared. So that's the application of breaking that down. And the most common error here is that students forget to do the power with the number. Okay, the power with the number. Often the students would typically write 5 there without realizing it's 5 cubed. That's the most common error. 5 cubed is 125 r cubed. S squared cubed means s squared times 3. So that is 2 times 3. So that is s to the power of 6. 10 squared is 100. R squared s squared. Now we use the law that when we're dividing, we subtract the powers from each other. But first of all, we've got a common factor of 25 here. Okay, so we can divide the numerator and the denominator by 25. And we can write this as 5 over 4. R cubed divided by r squared is r to the 3 take away 2, which is r to the 1. S to the 6 take away s squared is going to be s to the 6 take away 2, which is going to be s to the power of 4. So our final answer is 5 over 4 r s to the 4th. This could be written in a different way. So we could write this as 5 r s to the 4th all over 4. That would be an alternative way to write it, which has the same meaning as this one here. Okay, so that's an initial kind of example using some of the laws of indices. Right, let's move on and look at something a little bit more complex now. Let's look at some of the questions from question 4. Now in question 4, we've got some interesting ones. One of the laws that I didn't write down earlier is a to the minus n is equal to 1 over a to the n. And also a to the 0 is equal to 1. So we're going to be exploring and using these two as well. So in question 4a, for example, 3 to the power minus 2, using this law, this means that this is 1 over 3 squared, which in turn is 1 over 9. So the answer to 3 to the minus 2 is 1 over 9. If I've got 2/5 in this case to the power 0, well, anything to the power 0 is 1, so that would be 1. Okay, so that's what's going on there with those ones. Now, the next thing that I would want to think about is what is the meaning of something to the power of a half, and something to the power of a quarter, and something to the power of a third. So let's have a look at that. So let's say I've got, for example, x to the power of a half. What is the meaning of that? Well, x to the power of a half is another way of writing root x. It's the square root of x. If I've got x to the power of a third, that's another way of writing the cube root of x. And then if I have x to the power of a quarter, that is the fourth root of x. And in fact, I could generalize this. If I have x to the 1 over n, then that is going to be the nth root of x, like so. Okay, so those are just some different ways of writing down these powers. So let's have a look at a little example here. So if I had 4 to the power of a half, that is root 4, so that would be equal to 2. If I had 8 to the power of a third, that would be the cube root of 8, which in turn would also be 2. If I had 16 to the power of a quarter, then that would be the fourth root of 16, which would also be 2 as well. Okay, so that's just a little introduction to these quarter, third, and half, okay, what they actually mean. So let's have a look then, for example, if we were to have a go at question 4p. Question 4p, we have minus 8 over 125 to the power of 1/3. Now, we can actually cube root a negative number, and the reason why we can cube root a negative number is because a minus times a minus times a minus is equal to a minus. So therefore, it's okay to cube root a negative number. If we try, however, to square root a negative number, then that's a different matter altogether. And the reason for that is because a minus times a minus actually makes a plus. So you can, under normal circumstances, never square root a negative number. In fact, it is possible to square root a negative number, but we have to invent a whole new number system to do it. And that's something called complex numbers, which those of you who are studying A-level further maths will be familiar with. But for A-level maths, we don't need to worry about that. We can have a look at this one, and let's think about the fact that we have got minus 8. Well, the cube root of 8 is going to be 2, so that could be minus 2. And the cube root of 125 is 5. So this whole thing, question 4p, can be written as minus 2/5, and that's our answer. Okay, in the next video, I'm going to start looking at some more complex calculations with indices.